This is a breadboard and it is very useful in electrical connections. Now you can use this breadboard to test out electrical project before you carry out soldering on a PCB board. Now this is just one of the projects I was testing out on this breadboard. Now back to this, you need to understand how a breadboard functions so that you can use it properly. This red rail is the positive rail and they are all connected together. Then the next one, they are also the same, is positive, but the connection are slightly different. Now this is the negative rail, the blue line, and they are all connected together like the red rail. These lines too are also connected together, and we'll be testing out an electrical circuit, a very simple electrical circuit that you can try out right now with your breadboard. Now this is a simple LED bulb, a DC LED bulb, and we'll make use of jumper wires. Now this green jumper wire will be connected to the negative rail. This positive jumper wire, this red one, will be connected to the positive rail, but we won't connect it directly. We'll pass through a 1K resistor because we're using a 12 volt DC supply, and to prevent it from burning the bulb, we'll make use of this resistor, 1K resistor. Now we'll make use of our 12 volt DC connector. The positive wire is connected to the positive rail, and the red wire, which is negative, is connected to the negative rail. Now this is our connector, and this is how it turns on. This is a very simple circuit that you can carry out right now with your breadboard. Now, looking at the back of your breadboard, it can actually stick to something. The back is sticky. Once you remove the covering, you can stick it to something. Hope you understand, but for now, we won't be using that in this project. Now, you can make use of a capacitor also to get the current stable in case of power outage. Now take note of the negative side of the capacitor. That should be connected to the negative rail of the breadboard. Now when you test it out again, the capacitor is going to charge in the circuit. So if you remove the power supply, since the capacitor was charging, it will turn off slowly. Now when we do this without the capacitor, once we remove the power supply, the thing turns off immediately. Don't forget to like and subscribe.